course on the Linux and programming languages. Today we will be continuing our discussion on the Linux basics. Today is the lecture 3 of this 4-part series. So let's before we start our discussion for today, let's review what we did last time. So just a recap. The lecture 1 we talked about the basics of Linux. We went through like some of the file system, the kernel, the shell. In the last lecture we started talking about some commands. Specifically we covered several commands. One is the makedir to create the directory, rmdir to remove a directory, then rm to remove a file. We also saw the associated options and arguments. And we also saw some dangerous commands that we don't want to really use it unless we know exactly what we are trying to do. For example, the rm minus rf, which is a recursive and forced delete. And if you do an rm minus rf star or star dot star, and if you do it from the root directory, which is the flash that you know, pretty much like everything can be wiped out. And then usually in Linux, once the files are removed, it's permanently erased, so it's very difficult to get back. So we saw that, and then we also saw some editor commands like cat. We found out how to actually edit a file, and then we also like looked at the commands like less and more. Then we also did the cp command, which is the copying file from one location to another. We also like saw the variations of these copy commands, whether we copy a directory over or just a file over, what are the arguments for that, things like that. We also saw PWD, or the present working directory, to it's kind of like in a map it says you are here. Similarly, like if you do a PWD, it will tell you are here, or there exactly you are in terms of the hierarchy. We also saw some usage of special characters like the greater than, the double greater than, bang bang, bang dollar. Then this pipe command, I don't know whether we did that. If we haven't, we will do it in the next section. And then also semicolon. So you know that the greater than, the single greater than symbol, actually it's a command to actually add it into a file. So we could do like a cat, then greater than, then a file name to write into a file, and then if you do a control D, then you can exit out of that, so that whatever we write on the terminal will go into that particular file name. The double greater than is like append to that file. Bang bang is to execute the previous command. In general, like bang denotes that it is a command that needs to be executed. We will see this bang in other cases too. Like we'll talk about that, and then we'll see how we can do it. And then also we saw this semicolon, or that is basically a command separator. So in a line you can have multiple commands separated by semicolons, and the command interpreter will understand that as different commands and execute in a serial fashion. So pretty much now we know how to execute commands in a serial fashion, and also these various use of various special characters and things like that. So now let's see some activities that we can do based on the lecture 2. I'm just assigning you a couple of activities. One is try to use man. We learned about man in the first lecture. Use man to find more details on the cp command and also the rm command. As you know, like CP is the copy and RN is the copy. So just type man CP man RN, see what you get. In terms of activity, create a directory called lec2 in your home directory, and create a file called lec2.txt, and it should contain the following information. I have mastered how to create a file in Linux. This you can do it in 2 ways, so try both ways, and then also copy this file over to another file called mylec2.txt. So you see here in this mylec2, the way that we write it is basically start with a lowercase character, and then whenever there is a word boundary, we take the next the starting letter of the second word or the next word as an uppercase, and then we continue on. This particular way of writing is called the camel case. I think this will be preferred way to actually code in variables or file names, etc. You will see this more and more in future discussions when we go into the programming itself. It's easy to read. People also do like separate the words using underscore. That's another way to do it, but I prefer this camel case, which is also like very prevalent with a lot of programmers today. So now let's look at the topics for today's discussion. Now we will continue our discussion, and we will do some more deeper look into the Linux system itself. Today we will learn about how to manage the file access, what are the commands for doing that, and what do each characters or various types, what do they determine. And then we will also go into managing the system resources. This is another big topic as to how do we control the program execution. We won't go into a lot of details in today's discussion. We will only see how to access those the system resources. We will also talk in the next lecture as to how to actually really go into controlling the resources themselves. And then finally we will finish today's discussion with how to manage storage, which is also another key point, because in a general Linux machine, the operating system can assume that storage is infinite. Today the programs are becoming bigger and bigger, and as you know, like the operating system, once we start working on the Linux operating system, and if it is a Linux 64-bit operating system, you have like all the 2 to power 64 bits as the address space, which is like trillion or number of bits to be addressed, and so it almost looks as if like it's an infinite storage space, but in fact in reality, like I mean, we always have limited storage. So then we need to know how to control the storage, and how do we get information about how much storage is left, so that we can plan and manage accordingly. Because in reality the systems will have like 1 terabyte disk. So how do we make sure that we have enough space when we run programs? And we also look into like various types of memory, and typically, like I mean, so you heard about it, hardware resources, the RAM and the main memory, things like that. We will see like how those terms translate into the Linux system. So let's begin our discussion. The number one is the file access, as I mentioned. So in one of the key determiners of the security within Linux is because it has a very strict control on who can access the various files. So when you create a file, it's not that it is easily portable and basically anybody can access. As you know, the Linux system is a multi-user system, so even others can actually come and see your directories and things like that. but are they really able to see the file, or are they able to write into your file, or they can copy it into and they can execute from your place. So those are the key things that we will talk about. So essentially, like the file permissions, the permissions that you grant. So when you create a file, you are the owner of the file, and you can grant permissions to others, the level of access that it's possible. So a typical way to find out what the level of access on any given file is to use the ls-l command. And here we'll go to the next slide and then come back to this and talk about the permission levels. But I want you to read this one. The R means the read only, write, executable, execute permission, and then let's look at this. So here it's a ls-l command on a particular directory, and then it's ls-la or al, which also now gives us the hidden files which start with the dot and then the file name. So you look at on the left hand side, we see that there are some characters here. So the way to read this is the first one denotes the directory. Basically, if it's D, then we know that that is a directory, and if it is left blank, then that we know that that's a file. Then you have three sets of 3 characters each, and each one is RWX, and this is for this one particularly it's this R-X, and then the third set is also R-X, and this is always the same. Basically, it's RWX, and this could be RWX too, and this also can be RWX. So the way to read this is essentially like the first one, as I said, it's mostly then denotes what is if it is a directory or not. The first set of these RWX characters that denote the user permission, meaning what permission do you have as an owner of this file to access this particular file. So for example, the auto FSK, you only have read and write permission. So R stands for read, W stands for write, and X stands for execute. So in this this particular auto FSK, you have just read and write permission. And then the second the second set of RWX that denote what is the access permission for people who belong to your same group. So in this particular instance, you see the third column and the fourth column. The third column denotes the owner of this particular, or it's called the user of this particular directory, and then the second column, or actually like 1, 2, 3, fourth column is actually the group that this particular user belongs to. So again, the second set of the 3 characters is the permission that you are giving to the group, and finally the last 3 set you are saying that it's for everyone else. So for example, in this particular case, the particular directory is readable, writable, and executable if there are any executable by this particular user, and this group, it's also called root. The group get the permission to read as well as execute. That means that you can copy any files from this particular directory, and everyone else also gets the read and the executable permission, so that they can also copy as well as execute in this directory. So the same thing, like if you look at this particular example, the file.out, you can tell me what it is. It's again, it's a file that we know, and then this person who is the user gets the read and write permissions, and then all the others get just the read permission. So fairly simple. For example, this media gets the read, write, execute for everyone. So let's look at how we can control the access when we have like others accessing this these files. So the particular command called change mode is allows the users to change the permissions on for a given user. So in the change mode again we can specify the various options which are essentially the whether it's user group or others or all, and then what is the permission, and then the argument is the file name or the directory name. Actually like for the yeah, mostly it is the file name, and we see like how we can change it here. And then you can change the group permission of a given file just by using the change group. And change ownership is essentially if you want to transfer the ownership of the file from you to somebody else, another user. So then you can use the change on or the chon. So let's look at an example. Here the change mode we give 750 and file name. So one thing that I mentioned was the first set of 3, second set of 3, and third set of 3. These numbers can be expressed in binary actually. So you can think of this as a 1-bit stream essentially, starting from the first RWX, because the D is actually it's denoted by just the directory, whether it's a directory or not. So now if you look at this one, it's all like it assigns 1 bit at a time. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 bits in total, and each set of 3 can go from 000 to 111. So now tell me how many combinations are possible. So as you know, since you're all like electronic engineers, you know that actually there are 8 combinations possible. So you can represent numbers from 0 to 7. So for each of them you can represent either 0 to 7. We don't combine it and then we don't use any other thing. Basically we only like go up to a radix 8 notation. So the change mode has this radix 8 notation. So here when we say like 750, that means that the user gets the complete permission, which is read, write, execute, and then comes the 5 for the group, which is only the read and execute. So the middle number is nothing basically, and then finally the others cannot even read or write or execute, no permissions. So here essentially like so we can look at various things and see what the corresponding number is. So can you tell me like what the number for this copy directory is? If you look at it, it's 755. What about say the desktop? For the desktop it's actually 6 because it's 110, right, and then 6, 4, and 4. Easy enough. We'll give you some more practice ones that you can go through this exercise and then see how to use the change mode. And this particular shell also offers some uniqueness. Essentially, like we talked about this in the first lecture or the second lecture, I think, where it actually color codes the file names so that you know what is what. For example, the AXIRTL is actually it's a directory, and then AXIRTL.zip is like an executable or it's a binary file. And then the green is the text file, things like that we already know about this one. So we will see as to how the operating system determines what type of a file it is, and then how it can actually put together. Actually, in this case, like the make file is actually it's more like treats it as a script. It's writing like it's in black color. So let's look at that, and now we go into like some more system resource commands. One is how to report a date. So the command is just the date. When you give the date, it tells you like what is the current date and the time. So it gives you the day, the date, and also the time, and it gives you the time zone and the year. So a simple command. Essentially, this is used in programs. Then you want to print the start point. You just issue a command date, and then once the program finishes, you issue another command date, and then now you can actually compare in between how much time the program took, and then you can take meaningful actions based on that information. Okay, and then the next one is the change shell command. Essentially, this is to change the user's login shell. So you can actually like issue this thing, and then basically the system will prompt for what the new shell is. If you just type enter, then it retains it as the TCSH. Otherwise, it's changed to bash, for example. So it's an easy command to move from one shell to another. Sometimes like some programs are they do want a particular shell and they want to execute in a particular shell because it demands certain resources and certain control of resources. So this is an easy way to actually change the shell itself. Now let's look at how can we change the password. This is one of the important commands. So here the command is just passwd or password. It's called password, and then you can give options. I would like you to find what are the options available using man password or something like that. But in general, when you type password, the system will prompt you to enter the new password, and it checks against certain pre-specified rules. In this case, it's actually it is checking against the dictionary. So if you specify a dictionary word, it rejects that password because it doesn't want a password to be in the dictionary so that somebody can copy it very easily. The system administrator can set up various rules for governing the password. So he can demand certain length of the password, can demand certain special characters included in the password. Today most passwords in minimum of 8 characters needs a special character, a number and a case difference. So that kind of gives like a lot more authentication and so for the user. So once it you type in a valid password, then it updates the existing password, and there is a password file where all these passwords are kept. And I think like you can tell me like what will be the permissions for that one. So if you are listening to the earlier slides, the permission for that file that is protected and it's only system administrator can actually change that value. So in general what happens is when you type password, the password command actually gets control of that particular file, and then it lets you edit that file only for your entry, and then once you enter, then it's again put back, and then the permissions are reverted back, and then only the system administrator or the root user can really access that at that point. It's a not read, not write, not execute. I mean maybe execute only by the user. So if you in terms of the uh, the the numbers that we saw earlier, it could be like 0 0, or actually it will be 1 1. Actually, no, sorry, I'll take it back. It's 7 1 1. So as a group person or as an others, you can only do just um, execute, because you don't want to see others password, and you don't want others to see your password. Now we go into our second topic. This probably will take a long time, today's discussion. We already started talking about this, but I wanted to highlight what is a process in terms of in the context of Linux. So one key thing is when we talk about Linux, we talked about the kernel, we talked about the shell, we talked about the file system. Another key thing is also is a process. In Linux, any instance of a running program is called a process. Here, this is the exact quote from the Linux manual, which is actually listed here. The reference. It's a program, or the way they define it is as follows: a program is a set of machine code instructions and data stored in an executable image on a disk, and it is a passive entity. So a program, they call it as a passive entity, which is there in the disk, hasn't been executed. But a process can be thought of as a computer program in action. So when the program moves to the shell and starts executing, that's what is called a process. So what are the types of processes? For example, the shell, by the nature it's there and it is getting executed, that itself is a process. And any command that you type in, and then as soon as you press enter, that is a process, that becomes a process. So how do we know that what a process is? So the operating system itself assigns a unique process ID. The process ID is also called PID to every process. So it is a number that the operating system assigns to the particular process. So as soon as, internally what happens is as soon as you type in a command and press enter, the operating system takes over. It looks at that command. It first assigns a process. A process is a specific set of resources required to run that program, and then it starts that process and it assigns that process ID so that it can track at any point what is happening to that process, because the states of process is very important. The state could be running the process, or it's a waiting process, or it's a stopped process, or a zombie process. So we will see how we can distinguish these processes in a much later stage. But at least, like, I want you to understand that the way the commands are run is by using these processes. So one of the key things is how do we control these processes and how do we report these processes. That's what we will be learning in the next few slides. So to view the processes that you're running, the simple command is called PS, or process show. Essentially, if you do a PS minus all or PS minus A, that displays all the processes that are running on that particular CPU. Again, this is a multi-CPU system, Linux, but the way, and it's also a multi-user, so and multitasking. So the multi-user and the multitask is all represented in the PS. So you can just type PS minus A, and in this case actually PS minus AUX, which is essentially, which stands for the processes that are all the processes, including the user processes and the processes that are executing in the background, which is without a terminal, display all the information. That is the PUX. And then you can also specifically say like ps minus u and then the username, and then it will display the processes specific to that particular user. And here we use some command. This we will learn in the next section called the grep. And I also mentioned earlier that this pipe command, which is essentially the way to do interprocess communication. So interprocess communication we use many things. One is this pipe command. The pipe command gets the output of this ps minus aux process and then feeds it into the next command. So we know like semicolon separates the various commands. So far we have been calling them as commands, but once they start executing, like now that we know this term called processes, we should really call them as processes. So the semicolon is that process separator where it separates from one process to another, whereas the pipe command actually takes the output of one of the processes and feeds it into the next one. So here also like the program execution is still going to be like serial, but output can be fed into the next one. We'll also like encounter other forms of this interprocess communication. There are something called key and semaphore, which we will learn about in a later stage. So let's look at how this ps command is issued and what are the outputs. So in a simple scenario, when you type ps, this is a single user. This particular machine is used just by, or this particular session is used by just one user, and now it displays essentially like this information, which is the PID I mentioned, the process ID, which is 30380. That's assigned to the shell. So it starts from this particular terminal PTS5, and then it started at time 0, and the command is itself is the TC shell. And then since we type the PS, that PS actually started another process. That ID is 30494, and the process command is PS. So simple enough, and it can be more complicated than this, but at least like we will know how to display these processes. Now the process display is a passive display, meaning it's given at a point of time. But how can we look at least the system resources on an ongoing basis? We want to see how things change on a continuous basis, and when we are running a program, we want to know how much the program is taking, because there is no point in actually like running PS every time. We have to do it like every microsecond. So there is another command for that, which is the top. The top command is used to view the CPU usage of all the processes. It's basically just type in top, and then this process doesn't stop, actually this keeps running. So unless you press Q to actually quit from that. So here you can see much more details. Number one, it tells you what is the time that this particular CPU or this particular operating system is up and running. So in this case it is running for 2 days 42 minutes, and it has multiple users, 6 users in total, and there are 133 tasks total, of which only one is running. 132 are sleeping, and then nothing is stopped, and there are no zombie processes. So the task is synonymous with the processes, and as I mentioned, like the states are running, sleeping, stop, and zombie. So how much is the CPU utilization? Here it's only like 0.7% by the system, and then 0.1% is for the 0.7% is the user task, 0.1% is the system task, and various others basically. And then here we also have a concept of the memory. So usually there are two or three types of memories actually. One is the memory that is available. There is also some concept of virtual memory which we will talk about, and then finally the swap space. So so here we see that basically this has about 206 megabytes, of which about 117 actually it's about 2.6 gigs are available total, and of which like about 1.1 gig is used and another 894 meg is free, and then there are buffer allocated already in this one, and then there's a swap space which is a separate one which is of another 5 gig, and then everything is free in that swap space. And now you see actually the real meat of the command, which is it displays the process ID, who is the owner of that process, and then the various notations. This we will talk about it later. So here there is also like the virtual memory which is displayed as to how much virtual memory it is taking, how much resident memory it is taking, and then this is the shared memory, and then finally the CPU percentage, and then how much time it is running. So and this particular display is updated very frequently. It is not like it displays once and then it comes out. Basically, it keeps changing continuously. It is very similar to the task manager that we start in the Windows program, and it also displays on a continual basis as to how the CPU and the memories are consumed. Same thing here, and you can see that there are multiple processes and various parameters on that. And PR denotes the priority, and then this is the niceness basically. So we will talk about these additional things in the next lecture. So now an important thing basically, once you know like how to run the process, how to start a process, it is essentially give a command. But now how do you kill the process? This is also another key important things essentially. The command is essentially kill. So the kill is to terminate the process, and you can use the process ID as as um, as a way to identify which process to kill. And then there are options available for this particular command. Again, the argument is the process ID, and then the options are essentially the signals. So here the kill -9 means 9 is the highest level of that particular signal, which means that immediately kill and don't even worry about anything, like there is nothing, just kill the process. So the essentially it generates this signal called sigkill, which is essentially to kill the process for sure. There is no questions asked, just kill it. The kill 0 essentially means terminates all the current processes except your shell. So anything else is running, like this is like even without any arguments, just kill 0 and then it will kill all the processes that are running on that particular CPU. So once we also like know how to communicate and how to use the network, we will see like other commands to work with the load balancing systems. Probably like we will learn about that in the fourth lecture, the next lecture. So here this is the top command, or actually it's a ps-u, where it displays all the processes running by this particular user, and you have the process ID. So you kill this one, it's actually right here, this particular, sorry, the 30508 is right here, and that's the top command. So that one you can just kill it using the skill -9. Okay, so now let's go into some more commands to identify to use it for identification purposes. So the number one is who. As we mentioned, the Linux is a multi-user system, but you can know who are all logged in into the system by typing the who command, and it gives you the name of the user and also which terminal that they are using. Very useful command to see if your friend is logged in into your system. Also, you can see if there are any spurious persons logged in into your system. So just typing this who will get you like all the active windows and from where they are connected to, and then so these are their IP addresses, and then basically like when did they start. And then you can also again very similar to the PWD, which is present working directory, where hey, I want to know where exactly I am in this whole file system. Similarly, you can also ask a who am I essentially, and the command is just who am I, and that gives you the details about that particular window and that particular user who's using this one. Sometimes what happens is there are systems that are left by somebody else, maybe like there are windows that are open which you are not sure whether it's you are the owner and you need to kill it or you need to keep it going. So who am I is a nifty command to figure out whether it's indeed you who logged in into the system into that particular window or was it somebody else. So there are two variations here. One is, if you notice, actually this one is who, that who space am space I, and that gives you more details. And if you continuously type in just who am I in one word, then that gives you just your username. It doesn't give you like a lot of details more than that. Now we come to the third section, which is how do we control the disk space, or essentially. So one thing to note is in Linux we said that basically everything is through the directories, and essentially even disks can be mounted in various directories. So the various mount points are also given as directories. So you can, it's very easy to add additional disk space that if you want, or remove a particular disk also. So at any point people could remove stuff or add more stuff into the system. So one of the key things that we need to know is how do we what is the availability and how much disk space is there that we can use, and also if where exactly is that disk located. So the commands that we study right now are du, which is essentially, it stands for disk usage, and it gives you the options. I mean, you can give the options as well as the argument. Argument is the directory or the file. It gives you the exact amount of disk space in use essentially. So we will see like how this command gets executed. If the du minus sh, the file or directory, that gives the size of the file or the directory. And then the other one is the df command, the df minus h and the df minus kh. This one gives you the available space mounted on a file system. So the du is more like the particular file, the particular directory itself, essentially as to how much it is getting, how much space it is being used by that directory. Whereas a df will give you more information regarding the whole disk itself as to what is the available space, where is it mounted, and things like that. And then free is another command which gives you the amount of free space in the system. So let's look at an example with these. So here, so there is this home Nithin which has various files in the directory. So you do the ls and then you know all the things. Now you want to know, like, I mean, what is the size of this text1.txt. So you can say tu minus sh, just the text.txt, text1.txt, and then it gives you it's about 4K. You can get this information also by just using ls minus l that you already know about, I'm assuming, and that gives you on the 5th column, I think, will display the amount of space that the each of the file is taking. Typically for directories it lists as 0. So the du minus sh at directory will also specify, will give you the amount of space taken by that directory. Then the df minus h here actually gives you the particular file system, and as I mentioned, the disks are, even though they are hardware objects, they become directory. So which is in /dev/sda10. So /dev is all the disks are mounted on that one, and then here it's 112G is the size, out of which 110 is being used, and the use is actually 100% because 2 cannot be represented, so it's really 100%. So you need to go and like change this one. And then there is something called none, and then basically about 1 gig is there, and then all the things are available, and that is mounted on /dev shm. So now you also have this command free, and that gives you, like, I mean, how much is the total memory, how much is used, and how much is free. And then there's the shared memory, some of the buffers that are special types of memory. The cache area is another special one, and then how much swap space is available. The swap space is essentially required for swapping a program with another one. So processes, when you swap processes, you need this swap space. So I think this is probably the end of the lecture 2. So again, we talked about several things. I just wanted to recap one more time the things on the lecture 3. Essentially, like, we looked deeper into the Linux system. We understood how to manage the file access, the various permissions like R, W, and X, and then the various groups, the user group, and the everyone else. So how do we give access, as well as how do we change access of various files. We also talked about managing the system resources from the perspective of what is the process and how do we control the process. So again, we talked about one key aspect of the system resource, which is the pipe command. Essentially, how to pass the output of one process into another process. We will talk more about the processes in the next lecture, where we will go into some more additional commands like T and fork. A fork is essentially like T, and then the other one is the semaphore, basically, which is a concept to understand how the inter-process communication really works. We also talked about the storage itself. We differentiated between the memory, the swap, the virtual memory, etc. There are special memory elements like buffers and cache areas, which are locations, but you cannot write into it because those are used by the system itself for writing. And then we also saw how we can control or at least get information regarding the usage of the resources from these from using the commands like du and df and the free command. One thing that I will add is we talked about the various colored representation by the OS regarding which file it thinks it is. So as you know, in Linux or in with any the Unix type of operating system, you have you can write scripts that we will see more and more, and also we have regular files, the flat files. So the way to use or write a script is essentially we need to preface the script with whatever the shell that we want to use, usually in the form of hash bang. Then we will specify which shell that we want to use, like maybe user bin, wish, user bin, just sh will also work. So if we specify that line as the first line in the file, then the interpreter treats that file as a script, and then it actually runs that the script itself. It knows that it needs to execute. You still need to give the file permission as the execute permission, but the difference between a normal file and executable file is I mean executable file in the form of a script. The script is essentially it's a human readable program. So usually that one we will have that as the first line. So once again I want to thank you all for listening this lecture, and we will pick it up on the next one from this point. Thank you very much.